Hi, in this lesson, we'll learn about sorting with array lists using insertion sort. Let's get started. When data is disorganized, it can be hard to find values easily. Sorting our data first can make searching for data that much easier. If we wanted to find values, it's much easier to do if they are in the correct order. That way, we can organize our search at specific points, which in turn can make sure we are looking through less values when we search. The first sorting algorithm we looked at was selection sort. This algorithm sorts arrays by repeatedly finding the minimum value in an array and moving it to the front. The second sorting algorithm that we will look at is insertion sort. This sorts an array by sorting each element compared to the elements already sorted to their left. Let's see what this looks like in action. For insertion sort, we choose the first element and mark it as sorted. Then we choose the next unsorted element, which in this case is the value 3. We then shift this value into the correct position in the sorted part of the list. Now the left part of the list is sorted, and we choose the next unsorted element in the list, 4. The values on the left are shifted into the correct position so that 4 is placed correctly between 3 and 5. And then the left part of the list is sorted. The next unsorted element is chosen, shifted to the correct position, and the left side is sorted. The process continues until the rest of the list is sorted. So how can we implement this algorithm? Take a second to think it over. The pseudocode for this sorting method is as follows. Traverse each element starting from index 1. Then traverse all of the sorted elements from the left-hand side of the current index to find the correct element position, and shift sorted elements in order to place the current element. Let's dive deeper to see how we can write this out. First, let's focus on the initial traversal. We can write this out using a basic for loop traversal. In this case, we started index 1 because index 0 is technically considered sorted because there are not any other values to compare it to yet. The next step is to traverse the sorted elements to find the current element position. If we are on the final traversal at array.length -1, the current value of index 5 would be 2. Because the list to the left is already sorted, what we would like to do is check the value of each index to the left of the current index until the element has a lower value than the current index. Once we've found the lower value, in this case 1, we know that we can slide the current index value into the spot right after the index that hosts 1. We can write this out programmatically using a while loop. This necessitates a while loop because we do not know how many spots the current index needs to travel, but that it should keep going until it finds a value lower than it. This states that while the sorted index values are greater than the current index value, the current index should continue to shift. We also need to include sorted index is greater than -1, so that the sorted index doesn't continue searching after the list reaches index 0. We can write this out fully as such. Notice that we need to establish the sorted index value as index -1 and the current index value as the array value prior to the while loop so that the values do not continuously change while in the while loop. These exist within the for loop so that they change each iteration through the index value. The next step in insertion sort is to shift the sorted elements so that the current index is placed in the correct place in the sorted section of the array. We can shift the sorted elements by adding these lines of code. The first line in the while loop shifts each element left of the current index by 1. The second line shifts the index to the next lower index. Then, once the element with the lower value is found, we want to place the current index after the index that we found. The third line reads, array, sorted index +1, so as to place the current index, which in this case is 2, after the sorted index, which is 1. Altogether, this is the code that we can write to create an insertion sort. Here's a visualization of the insertion sort after all is said and done. Notice that this sort method grows from the left, as the left section of sorted values is growing as the list sorts through each value. If we take a look at the insertion and selection sort side by side, we can see how they differ. While insertion appears to move from left to right, the selection sort appears more scattered in its approach. This is a result of swapping each value as opposed to shifting the values. So, which algorithm should we use? And why do we have more than one way to sort? The efficiency of each sorting mechanism depends on how sorted the list order is at the start of the sort. Given that both sorting mechanisms use different strategies to search, the approach impacts which types of lists are best for each sort. Suppose we had two arrays. Array 1 is an array that is almost sorted, and array 2 is in reverse order. Because array 1 is almost sorted, insertion sort is a more efficient option. The while loop in insertion sort will only run if the value directly following the current index is greater than the current index. If the list is almost sorted perfectly, then the while loop won't execute for most of the traversal, lowering the execution count that will take place when the array is sorted. Alternatively, when the array is completely reversed, selection sort is more efficient. Insertion sort has to shift every single value when executing the while loop, as every value is greater than the one that came before it, while selection sort will only swap two values, 4 and 0 and 3 and 1, before being completely sorted. As a result, the execution count is much lower for selection sort in this particular case. Just as we had used statement execution counts in previous units to determine the efficiency of a program, we can use them again to compare the efficiency of the different sorting algorithms that we come across. It's important to consider execution count and efficiency when deciding which sorting mechanism to use. Now that you've learned more about sorting, let's get some practice in the editor.